Okay. All right, I think I'm getting used to this. So we're going to backtrack just a little bit for those who did not get the ionic bonding teaching and understanding. So let's do a quick review on the atomic structure. Remember the helium atom, which has 2 electrons, 2 protons here, and those are the main subatomic particles we need to be thinking about. And then we also have lithium with 3 protons, 3 electrons. Notice how lithium, we have to add an extra shell. Remember, the first shell only holds 2, like you have in the helium, and the second shell will hold up to 8. So we start filling it in with the next electron. So since we need 3, put 2 in the first and 1 in the second. And the way this actually bonds with another element is like this. You take a lithium with the 3 protons, then make the first shell with 2 electrons there, and then 1 in the outer shell. We'll put those in with red. So you got 2 here, 1 out here. And then let's say it bonds with a fluorine. We'll make some lithium fluoride. Okay, so the lithium fluoride. In fact, let's just go ahead and make sodium fluoride. Since you're already familiar with the lithium there, we'll do a different one here to give it a little more understanding. So if you have sodium, which is going to have 11 protons in the nucleus, 4, 5, 6, 7, 8, 9, 10, something like that, 11. Then you're going to have also 11 electrons. Put those in quickly. So we got 2 here, 3, 4, 5, 6, 7, 8, 9, 10. 2 in the first, 8 in the second, just like we said here. Well, then that leaves us with 1 more, because you got to have the same number of electrons as you do protons. We had 11 protons because it's atomic number 11. And remember, that determines the number of protons, the atomic number. That'll be, of course, in the upper corner of the box on your periodic table. So if we have 11 protons, we need 11 electrons. So sodium here, then let's go ahead and draw fluorine rather quickly. So fluorine with 9 protons in the nucleus. First shell is going to end up with 2 electrons. You got to have the same number. So 2 plus 7 in the outer shell will give us 9. So 2 electrons in the first, 1, 2, 3, 4, 5, 6, 7 in the second. So what is going to happen? Well, is fluorine going to try to gain 1 electron or get rid of 7? Well, obviously it's easier to just gain 1 electron. Sodium, on the other hand, would rather just get rid of this 1 electron. So sodium says, hey, fluorine, would you like this electron? Fluorine says, heck yeah, I'll take it. So sodium gives up the electron. Now, why does it do that? Remember, the rule is that all of the elements want to be full in their outer shell. And so they make adjustments according to the electron configuration. Getting rid of, or that is transferring electrons to some other element, or gaining electrons from some other element, as the fluorine does. So in the process of the sodium giving up 1 electron, it becomes slightly positive because it lost a negative. So it technically becomes a positive 1 charge, while the fluorine gaining the electron becomes slightly negative and becomes a negative 1 charge. So while they become slightly positively charged and slightly negatively charged, they are essentially becoming ions. And so ions, let's just put that down here, ions are charged particles. And a charged particle is attracted to the opposite charge. As you know, opposites attract. So same principle applies in these ions. And this is the reason we call this ionic bonding, because the ions are being formed as they as they combine in a compound form. The electrostatic attraction between the two holds them together as a compound. Now, let's look at what the actual formula is. As you put the two together, you end up with sodium fluoride. I hope every one of you has enjoyed the use of sodium fluoride. Remember, it's in toothpaste. And it's also what becomes reactive in your mouth. Cause all the foam and get your teeth nice and clean. All right, well, that's enough for ionic bonding. We will probably put this back on the ionic bonding week, which should be week 2. All right, guys, God bless.